Every day, thousands of surveillance cameras capture millions of traffic images. But here is the reality of the problem. Taking the photo isn't the bottleneck. The bottleneck is the human cognitive load required to extract actionable intelligence from raw pixels. Manual inspection is slow, subjective, and fundamentally unscalable. The real challenge isn't building that an AI detects a car, it's building an intelligence trial system that eliminates noise, handles brutal real world conditions like low light and motion blur, and operates at a massive scale without astronomical computing costs. We need to bridge a gap between a raw camera feed and a legally defensible traffic situation. That is why we build traffic violence. Okay, so how do we solve this? By shifting away from monolith, brute force models and instead using a highly optimized multi stage computer vision pipeline. First, we solve the environmental challenge. Before the AI even analyzes the image, our feedback loop enhancer automatically corrects for low light, shadows, and motion blur. Secondly, we solve the accuracy challenge. We pair a lightweight YOLO V8 architecture with custom train weights, like a proprietary helmet detection model, to achieve surgical precision across different vehicle and rider classes. But here is where we made the most value. We don't just blindly flag violations. We introduced a proprietary evidence defensibility score, that is EDS. Our system mathematically evaluates the confidence of detection, the clarity of the license plate, the severity of the rule broken. If the autonomously routes the data, it then autonomously routes the data. Crystal clear violations are instantly prepped for auto ticketing, while edge cases are routed to human review. We aren't just replacing the human operator, we are supercharging them by reducing their workload by over 80%. So, here is also our pipeline which you can see. First is data ingestion. So, CCTV fleet, there will be all cameras in the city which will capture the images and all. So, it will go through ingestion gateway. Then that is basically data ingestion is all about capturing the photos and uh, compiling them and feeding into our system. So the second one is our ML processing pipeline. This is our main where the detection and everything takes place. First happens is the image enhancement, which goes through feedback loop enhancer, which measures, corrects, and then repeats till it achieves the perfect form. So you can see here, these are the metrics which we used. It converges in 1 to 3 iterations. Yeah. Stage 2 is object detection. So we used YOLO V8 at specific metrics and proprietary weights, which detects the vehicle first, and we detect auto rickshaws, bus, car, motorcycle. Then comes the violation rules engine. So this is the detects the all the violation which the rider has done or the person driving the car, which is seat belt, illegal parking, or the wrong side driving. So we have used spatial geometry on all the geometrical calculations which will calculate if there is a violation or not. Like for example, for helmet, we introduce a system which uh, checks if the head of the person is very symmetrical or not, and few more such that calculations we have done to calculate to basically conclude if there is violation or not. Stage 4 is license plate OCR, which is obviously the OCR which we are doing, which is yeah. Huh. Then stage 5 is evidence generation. So evidence generation is we use temper evidence. So content hash, image hash, violation hash, we use them to you can say to avoid any clashes between two of them. So and then there is also you can download a PDF of that violation which is code ready. So it has all the information and the screenshots and number plate and etc etc. Stage 6 is EDS scoring and triage. So evidence defensibility score, as we discussed just right now. If it is greater than 75, it get automatically reviewed. If it is less than 75 and 40, between the range 45 and 74, a human will manually check if it is correct violation or not, if the number plate is correct or not. He can make changes in that. And if it is very less than, let's say, 3520, it will be discarded. Then there is routing, which I this is this one, yeah. Auto issue, human review, discard. This is what I just discussed. Then there is data persistence and integrity. So it is all about the databases. We use hash chains. So record hash, previous hash, content hash. So we are basically combining them and uh, storing them as a one database, as a one violation. Then there is object storage, evidence storage. Yeah. So image and everything gets also stored in our database. Then there is output integration. So this is what we can uh, do it later in the later stages. That is e-challenge system, office dashboard, analytics and reporting, citizen portal, external integration. So external integration, as I said, Vahana Parivahan database. If we directly integrate that to a system, we will be able to get the drivers or the person owning the vehicle's information just by the number plate. So these are few examples that we can output and integrate. So this is our overall main pipeline, the overall flow of a project, how it works and how it runs under the hood. So yeah, it has been hosted on a serverless GPU, and yeah, that's it, I guess. Yeah. So till now we discussed how. Okay, so till now we discussed that why our solution is relevant and all. Secondly, we discussed how we are solving the problem statement, and third, we are going to discussing is what our solution does. All right. So it is a complete, scalable, end-to-end platform built on a React and Fast API. You upload an image or batch process, thousands of them at once, and the system goes to work in milliseconds. It detects vehicles, pedestrians, and riders. It identifies 7 distinct violations which were mentioned in a problem statement, from helmet non-compliance and triple riding to wrong side driving and red light jumping. It extracts the vehicle's registration number using targeted OCR, but we didn't stop at detection. So first of all, let us look at an example. So I've uploaded an image right here. So when you will upload, you will this is the original image and this is the annotated plus enhanced image, which has gone through the all the feedback enhance loop and all. So yeah, you can first of all, there has been animations like you can zoom in. So this guy is wearing a helmet. All right, this guy is also wearing a helmet. So there is a green box which mentions helmet. So this is an animation part. Secondly, if you scroll down a bit, you will see all the violations in that photo. So first of all is, let's say, this one, red light violation. So let's say there was a red light if this car was moving or something like that. So here we go. Yeah. So this box has been cropped. This car has done, let's say, a red light violation. So this is the number. This is as you can see, the number plate is not directly visible, although it has attempted to capture the number plate, but it has failed. So this is our example. This is flagged vehicle. This is number plate. This is what we store in our database, and that's it for the evidence. Yeah. So such that there are many stop line violation, etc., etc. You may see this gas. Yeah. So yeah, this one got auto issued. This guy. So auto issued, why? Just because his EDS score was greater than 77. So what EDS score contains of violation confidence 61, image quality 96. Image quality would be same for everyone. Image clarity 75. Identify plate confidence. So plate, how much the plate is visible, that also contributes to the EDS score. So EDS score is basically which will route. if it requires an human intervention or not, or it has already automatically resolved. So that is it. So, but we didn't stop at detection. Traffic violence automatically generates a code-ready evidence (PDF). This document includes the annotated image, the contextual cropped license plate. Just a second. Yeah, so but we didn't stop at detection. Traffic violence automatically generates a court-ready evidence PDF. This document includes the annotated image, the contextual cropped license plate, a plain English explanation of the offense, and a cryptographic hash chain seal that guarantees the evidence is 100% tamper-proof, so that nobody can use a misuse or make changes in the database manually, so that there would be a change in evidence. So no, it is tamper-proof. Finally, all of this data flows into a real-time analytics dashboard, giving traffic analytics dashboard here. So, giving traffic authorities instant searchable records and macroscopic trends of citywide violations. So, this was the overall. I will explain the analytics tab and everything. Just a second. Yeah, so on opening, clicking on the analytics tab, it will open it. It might take few seconds to boot up because the our backend is in our model, so which has some cold start issues and all. So this is our system analytics dashboard. It will show the total violations till now up to date, average confidence plates identified till now. This is the uh, what we say violation by category. This is the distribution. This is the you can see the trends in violations which was mentioned in a problem statement which you guys required. So you can see the number of them and all. This is distribution. Then there is this, yeah, there is the database. So how we are storing. So this is bbox. The bbox is basically the annotated box which we saw earlier. Severity, timestamp, confidence, image hash. Description is basically like that's yeah. Description. I was speaking about violations record history. So bbox is basically which we discussed. Image hash, description, violation ID, violation type, plate confidence, violation ID. So this is all a chain found on a about a single violation, which gets stored in a superbase of Postgres, SQL, anything like that, which you can host. So this is how we are storing all the violations based on their violation ID. So you can search them based on the violation ID, or you can search them by the plate vehicle plate. Like so, this was it for the violation record history, the distribution violation by category. This was all about our analytics page. Let us move on to the evaluation. So evaluation is one of the most important about our history. So, yeah, as it was mentioned in the problem statement, they asked about detection F1, mmap, violation F1, exact match, precision, F1 score, and all of that. So, how do we actually calculated these score if you are wondering? So, we basically manually uh, did some the mapping and targeted mapping on all those 18 images. Based upon that, we have calculated the precision recall and all. So this has to be done only once. If it has done once by a human, which is 100% accurate, so then all the new images will be calculated against them and all that. So that is how we calculated F1 violation, F1 plate exact. So we have object detection. This is the first step. Per class detection. So car, person, bus, truck, motorcycle, auto, bicycle, everything. This is violation classification and object detection. Yeah, license plate recognition, exact match 56. So this one is quite low just because it totally depends upon the image quality. If the image quality is high and good, which I'll show an example of that too. So that would instantly work. Computational efficiency and scalability. So this is again one of the most important. So the calculations can be done either on a CPU or a GPU. On CPU, you can see the latency is high and throughput is very low, so which is obviously not what we want. So we will use in real life if we have to implement this on a real scale city. We will use a cluster of GPUs, which will basically reduce the latency and increase the FPS. So we can actually then calculate a lot more images per second compared to CPU, which we are actually doing right now. So per violation type, this one is the how yeah all the seven violations it is regarding the TPFP, FNE, all that. This is confusion matrix. This is an interesting part violation classification. So the this one is all the seven violations are recorded right here. This is the predicted one right here, the horizontal one, and actual is the vertical one. So you can have a graphical view of all the predicted versus actual. You can see some in red and some in green. You can have a good insight about our system. The robustness benchmark, yeah, so low light, this is where we excel. Basically we improved 19.4%. Motion blur was our hardest. Motion blur and rain. Rain we can improve a bit, but motion blur is quite difficult to do. It requires a powerful GPU and all the stuff which was not readily available to us. So we are actually not that great in that aspect, I would say. But other than that, excellent. So this was about our performance evaluation tab. Now let's go to about. About is basically explaining a pipeline, violations, what makes its difference. Explaining this is all about us. Let us actually get into an example. So when you will open up the website, you will be greeted with this landing page. So there are the demo images which I've put upon. So let us try one of them. So yeah, you can also upload if you have an image. This is batch triage. You can upload a bunch of images at once, all at once. So it will also behave as same. All the violations will be stored at database. Just that you won't have to manually upload a single. So let us try one of our demo images only. So this is helmet violations. It might take few seconds to a few minutes depending upon the cold start and all. So let's wait. Yeah, so within let's say 30 seconds this image got processed. So this is our annotated. If you look, if you can, yeah, let us scroll. Helmet violation. This is the first one. So this guy is obviously not wearing an helmet. The image quality was blurred, so the number plate crop was not possible. We have already discussed this one. Yeah. So this one was helmet violation. EDS was 62. If you want, the severity was high, 94%, 60% is the confidence. So let us download a PDF. So if you click on the this button right here, which will download a PDF. It might take a few seconds. Let us wait. Yeah, so it just got downloaded. So this is the structure. Content hash, record hash, sealed at, this is a timestamp and everything. So this was actually number plate, but it is not possible in this image actually. I will show you an example right now about how the number plate also gets detected if the image quality and everything is great. Let's move into that example. So this is another example. You can see how the image clarity improved and contrast got boosted and everything. So this was a triple writing case according to a system which got auto reviewed EDS of 90. Let us look at the evidence. So this guy right here was probably triple riding or doing something. He was wearing helmet. Yeah, he was wearing helmet. It got flagged as wearing helmet. Yeah. So number plate. It has successfully cropped the number plate, which is K18AG. Also captured the number plate correctly. This is OCR confidence and all. So this was another example. If the image quality is great and everything, if it is actually visible, then only it will be captured by our OCR. This was our all about our project. This is a landing page. You may try all of our demo images if you wish. All of them are present right over here. And yeah, this is it. Thank you for watching.